Hello class, welcome back to the second part of this lesson. We are looking today at how to expand numbers, what we call binomial expansion. These are terms which have two numbers and then they are expanded by a particular power. From 0, we are going to as far as we can, but for our focus, we'll go from 0 up to power 4 for this lesson, for today, to learn a few basics. So we've seen here how to raise a binomial expression raised to power 3. In between here, the sign is positive. Now the question comes in, what if you are raising a number and in between the sign is negative? Okay, I'm going to write it on this side so that we can compare and contrast them. So a minus b power 3, as you already said, it is the same as a minus b power 1, a minus b power 2, because these ones will give us that one raised to power 3. If this one raised to power 1 is just a minus b. This one raised to power 2, by now we should know it will be a squared minus 2 times a times b, 2ab plus b squared. Then we do the same thing as we did here. We now multiply this by that, so multiply this by that. We are going to get an interesting observation. This by this will be a power 3. This by this is minus 2a squared b. This by this is plus a b squared. Let's see here, ab squared. Then this by this we'll have a minus b a squared. This by this will be plus, because we're making a negative and a negative, that gives you plus 2ab squared. This by this is minus b cubed, because negative times positive is negative. Now again, if you look at this, what we have here, we have 2a squared b. Let me rewrite this one a bit here. It is like a squared b. And this by that is 2a squared b. This by that is ab squared. This by this is minus ba squared or a squared b. So if you look at these expressions, this one and this one are like terms, because it is a squared b, while this one and this one are like terms, because it is ab squared. This should be 1ab squared, where 1 is the coefficient here. We don't always have to write it. And this is 2ab squared. So let's combine them. We'll have a cubed. This and this will give us minus 3 a squared b. This and this will give us plus 3 ab squared, then minus b cubed. What does that tell us here? In this case, normally we don't write the coefficient 1 if it is 1, but this one should be 1. You can see when you're expanding a binomial expression where there's a plus in between, the first term is always positive, second positive, and all of them are positive. But when you multiply a binomial expression where there's a minus in between, the first term is always positive. This should be 1. The second term is negative. The third term is positive. The next is negative, and it goes on and on and on. That's one important thing to note. If the sign in between is negative, then your answer will alternate between positive, negative, up to the end. While if your expression here, if your sign is positive, all of them will be positive. Another interesting thing to note is the coefficient. Coefficient here is 1. here is 3, here is 3, and finally it's 1. So 1, 3, 3, and this will be 1. So let's note that when we are multiplying by power 3, when you are multiplying to power 3, then our coefficients are 1, 3, 3, and 1. This is the power 3. Coefficients are 1, 3, 3, and 1. And then another thing that is of interest, when you are expanding to power 3, the first expression here is only a, which is the first one, to power 3. The second one will be having a power 2, which is reducing by 1. The next will be a power 1, and actually the last one should be a power 0, which we don't even write because it's power 1. While here, there's b power 0, so we don't write it because it's 1. Here there's b power 1, so we write the b. Here there's b power 2, and finally b power 3, which was the power by which we were expanding. Very interesting. So the two terms that you have here, the two terms that you're going to have here are going to be such that this one will be raised to the power that you're multiplying, and is the first term a. The next term a will be power 2, it reduces by 1. The next term is a power 1, and the next term should be actually a power 0, so we don't write. While the second term b is b power 0, so we don't even write it. The next will be b power 1, and then b power 2, and the final one will be b power 3, which is the power by which we were raising it. Let's see if the same is true for power 4. Raised power 4. Now that we know if it is negative, it keeps on alternating, this will be a bit easier. So what is a plus b raised to power 4? It is the same as a plus b squared, a plus b squared, because square 2 plus 2 will give us the 4. The base number is the same. That's the laws of indices. And then you already know what a plus b power 2 is. It should be a squared plus 2ab plus b squared. And the other one will also be the same. A squared plus 2ab plus b squared. And then now we multiply this by the whole of that, this by the whole of that, this by the whole of that. What are you going to get? A squared times a squared will be a power 4 plus a squared times 2ab is 2a squared b. See, a squared, so 2a power 3. A squared, this 2a power 3 plus this one times that, a squared b squared plus this one times this one, 2 a power 3 b squared b 2 a power 3 b, this times that, plus 4 a squared b squared, this times that, then this times that, plus 2 a b power 3 plus the last term here multiplied by the whole of that. So this times this will be a squared, a power, let's see, this will be a squared b squared, this times that, a squared b squared, this times that, plus 2 a b cubed, then this times that, plus b power 4. So multiply by this, finally the last term, this by this is a squared b squared, this by this is 2ab power 3, and then this by this is b power 4. So do we have like terms here? The first term that we have, of course, will be a power 4, that one. Here we have 2a power 3 b, 2a power 3 b. So this one and this one are similar. That gives us plus 4 a power 3 b. Then we have a squared, b squared. Here we have a squared, b squared. This one's, let's see, this one should be 5a squared, b squared. Then we have this one and this one. That's 4ab power 3. Then we have plus a squared, b squared plus b power 4. This is the last one, and this one was remaining. But if again you look at it, a squared, b squared and 5a squared, b squared are having a like term. So we add this and that. So what are we going to get eventually? A power 4 plus 4a power 3b plus, if we add this one, it will be 6 a squared, b squared plus 4ab power 3 plus b power 4. So if you look at it, the coefficient here for power 4 are, this should be 1, 1, 4, 6, 4, and 1. If this was negative, it will be positive, this will be negative, positive, this will be negative, and then ultimately positive. And the same rule applies. We're raising to power 4, so it's a power 4, then a power 3, a power 2, a power 1, a power 0. While for b, it should be b power 0 here, b power 1, b power 2, b power 3, and finally b power 4, because we're raising it to power 4. So what have we learned in our lesson? We have learned what we mean by binomial, a term that contains two numbers, like a plus b or a minus b. Expansion, we have seen how to raise it to a particular power. And then we have worked out a few examples to show how we get, what happens when we expand a positive binomial expression or a negative binomial expression. In our coming lesson, we'll be looking at what we call Pascal's triangle, which enables us to get these coefficients, as you've seen here. We've seen for power 3, for power 4, and obviously power 1, power 0, 1, and 2. See you in the next lesson.